For a direct variation, y equals kx, so y varies directly is the value of x. Inverse is y equals k over x, so as x increases, y decreases, vice versa. Joint variation is y equals kxz. Some of the steps are, the first one is write the equation, second, find k, third is rewrite, and fourth is find the remaining information. Alright, so for direct, the question is, in a store, the profit varies directly with inventory. What you really do is just find what the variables are with the equation. So P is 1,000, I is 25. You want to find P when I is 50. So you're really just doing a proportion and multiplying it by 40. So P would be 50 and then times 40, and you get 2,000. The inverse is if y varies inversely as x and y is 32, when x equals 3, I just want you to find x when y is 15. So the first steps, you're going to have the equation y equals k over x. You're going to plug in your numbers, 32 for the y and 3 for x. And you're going to get 96, and then you're going to put it in this form, the y equals 96 over x. Then you're going to plug in the 15 for what you had, and it's going to be 15x equals 96. So then you're going to divide and get x equals 32 over 5. All right, so for the combination word problem, what it is if y varies directly as x and inversely as z, and y equals 24 when x equals 48 and z equals 4, you want to find x when y equals 44 and z equals 6. So you're going to use the formula y equals kx over z, and so you just plug in what you have, y equals 24. Then you have k multiplied by x, which is 48 over z, and z is 4. And so then you have 24 equals 12k. So you simplify that and get 2 equals k. And then for k, you just plug in that. So you're going to have y equals 2 times x over z. You're going to get 44 as your y. That's what I want you to find. And then you're going to have 2x over 6, because that's what z is when it's 6. And then you basically just multiply, and you get x equals 132. Simple as that.
Here's the you try problem, and the answer's in the bottom right corner.
If you want to pause the video, if you want to, that'd be good.
Unit 3, Part 2, discontinuities, horizontal asymptotes, x-intercepts, y-intercepts, and domain of rational functions.
Alright, so the definitions are pretty self-explanatory. Discontinuous is a break in the graph. Holes is a point that doesn't exist, so it basically cancel out. We'll show you an example. Vertical asymptotes, it's just an imaginary line on the y-axis that the graph comes close to. The horizontal asymptotes is the opposite, which is imaginary line on the x-axis that the graph comes close to. So with the x-intercepts, it's the point where the line crosses the x-axis, and y-intercepts crosses the y-axis. So the y-axis. So the domain of rational functions, all the x values, it's all the x values on the graph. Alright, so I'm going to explain, this is Harrison, I'm going to explain the first half of this, and Spencer will explain the second half. So in this equation, we have x plus 1 over x squared plus 3x plus 2. You're going to want to factor out what you can, so that's the bottom half. So it's going to be x plus 1 and x plus 1 on the top. You're going to cross that out, but you're going to take the x plus 1 and set it equal to 0. So your y value, or your x value is going to be minus 1. And then you just take what you have and plug it back in, and you're going to get 1, and just plug that on the bottom of the denominator for the x plus 2. Just plug it in for x. For your vertical asymptotes, you are going to want to just set your y values, or you already have one of them, that's the whole, and then you're going to want to set the other one equal to 0, so you just have x plus 2 equal to 0. It's going to be minus 2. For the domain, Josh will tell you about that, and so on.
For the domain, so it's all the x values, and the excluded x values are going to be -1 from the whole, and also -2 from the vertical asymptote. So it's going to be -infinity, comma -2, union -2, comma -1, union -1, comma infinity. And then for the x-intercept, there's none, because when you plug in 0 for y, it's 1 over x plus 2, and you multiply x plus 2 across, and 0 equals 1, so that doesn't work. And then for the y-intercept, it's going to be 0, comma something, so you plug in 0 for the x value, and you get y equals 1 over 2, so it's just 0, comma half.
All right, this is Unit 3, Part 3, adding, subtracting, multiplying, and dividing.
So now the multiplication section. So with step 1, you have x squared minus 4x over x squared minus 16 times 15xy squared plus y squared over 3x squared plus xy. And then for step 2, like, you simplify them more. So like for the x squared, you got a GCF and you take out the x and then you have the parentheses, so it's x minus 4. And then you do that over x minus 4 times x plus 4. And then that's still multiplied by 5y squared. And then in parentheses 3x plus y, because you took a GCF out. And then that's over x times 3x plus y, because you took an x out. So after that's simplified, then you can eliminate some of the same numbers, and so you do that for step 4, and then you get 5y squared over x plus 4, and then that's your final answer. And then for the division section, so you have, the problem is 4 minus x over 3x plus 2 times x minus 2 divided by 5 times x minus 4 over x minus 2 times 7y minus 5. So what you do for step 2 is you keep change flip. So what you do is you put the division sign to multiplication, and then you flip the fraction to the right. So you have the opposite. And then step 3 is, let's see, you just do the same thing and multiply. And then for step 4, you get -1 times 7y minus 5. And then 3x plus 2 and 5 as the denominators. And then that equals -7y minus 5 over 5 times 3x plus 2 equals, for our final answer, -7y plus 1 over 15x plus 2. Alright, so now the addition section. So the problem is 3 over x plus 2 plus 2. And so that converts to 2 over 1 times x plus 2 over x plus 2. And so what you do is you need a common denominator, so times x plus 2 to the 1, that's the denominator of 2. So what you get is 3 over x plus 2 plus 2x plus 4 over x plus 2. And then you can add them and you get 3 plus 2x plus 4, which then simplifies down to 2x plus 7 and over x plus 2. And that's your final answer. Now for the subtraction section, you got step 1, -5x minus 1 over x plus 8. And you subtract that by 3x plus 4 over x plus 8. And since the denominators are the same, you can subtract the numerators. And so what you get is 5x minus 3x minus 1 minus 4 over x plus 8, which then simplifies down to 2x minus 5 over x plus 8 as your final answer.
Unit 3, Part 4 and 5, solving radical equations and simplifying complex fractions. Okay, for simplifying complex fractions, complex fraction is a fraction that has a fraction in the numerator and denominator. So first, our example is going to be 1 over x plus 3 over 5y plus 4. So step 1 is to get the common denominator. And so on the bottom, it would be over y, and on the top it would be over x. So then once you get both of them, then you divide. So it would be 1 plus 3 over x. 1 plus 3x over x divided by 5 plus 4y over y. And then when you divide fractions, you flip the right one and you multiply by it. So your final answer, you get y plus 3xy over 5x plus 4xy. And for solving radical equations, a radical equation is an equation that has at least one variable within a radical. So the example is the cube root of 2x minus 4 equals negative 2. So first, you want to cube it. So you put it to the third power on both sides. So you cross out the root, and so you get 2x minus 4 equals negative 8. And then you add the 8 over it and divide by 2, and your final answer is negative 2.
All right, here are the U tries, and thanks for watching.